Right. Okay. So hope you're able to see my screen.
Yes,
Yep, the APAC OEC one.
correct.
Right. Thank you. So welcome everyone to 2020 APAC Groundbreakers Virtual Tour by APAC OEC. This year, our event would be the biggest one ever done with 174 sessions, including normal sessions, workshops, and hands-on labs from 123 different speakers over 11 days. Also, it would cover sessions on 4 different languages. Please remember to register as many as sessions you can, and all sessions would be available to replay as many times you want 2 weeks after the initial sessions. You can also interact with the speaker at any time during the 2 weeks of posting questions directly into the playback session page. We would like to say thanks to all our Oracle user groups, Java user groups, and to our sponsors, Oracle Groundbreakers and CloudDB, for making this event possible. And with that, we have today welcome Christopher Jones for presenting using the Go language for efficient Oracle database applications. And you can ask questions in Q&A chat tab, and we will take the questions at the end of the session or in between, wherever Christopher feels comfortable with that. And with that, I will leave to Christopher to share your screen and start the session. Thanks, Christopher. Thank you so much for your time.
Thank you. Let me just get myself organized.
All
And
you're up.
Webby, looks good to me at this end. Let's make a start. So my name is Christopher Jones. I am a product manager in the data access team for Oracle Database Group. So I'm a sort of general technical person in that group with a number of responsibilities to try and make sure that great technology gets to you as users and that we understand what you as users are trying to do with our technology. Get to write code and documentation and do demos like today's. I hope you do enjoy this presentation. My colleague Sudarshan Soma, I think, is online to help answer questions if you have any questions. You may have seen his name and that of Anthony Tuaninga, who's also a player in this space on the GitHub repository if you've already looked at some of the drivers we're talking about today. So my wider group, just to start off, looks at a lot of database access APIs into Oracle Database. I don't know whether we call them drivers or APIs or modules, but they're the things you use to actually make your SQL statements execute and get results back to your drivers. Myself, I'm focused on the sort of C stack, and mostly this open source stack here that you can see, Python, Node. We're looking at Go, do some work with Go, with R and PHP. I spent a lot of my time in past years looking solely at PHP and have now spent the recent years with Python and Node, starting to do some more work with Go. I liaise with some of these open source communities as well, and thanks really go to the maintainers of these drivers who don't work for Oracle. They do this in their spare time, making great technology available to you in whatever language you'd like to use. I also, by the way, have overall responsibility for Oracle Instant Client, the packaging we're going to talk about. So if you have some questions about that, you can hassle me. I can pass you on to either the owner of the particular layer or tool, or answer it myself. So let's get into Go in a couple of slides. I've got a lot of demos, so we'll be mixing backwards and forwards between some slides and some code. What is Go? It might be new to some of you. It's a compiled general purpose language, grew from the history of C and the rise of interpreted languages. Things like C++ are very slow to compile. Python and Perl and all these interpreted languages tend to be really fast in that regard, but then slow at runtime. So Go attempts to solve both of these issues to make a fast compiled language for you. Where is it at the moment in the popularity stakes? There are a number of surveys out there. I just got a couple on this slide. One at the moment, this is the TOB index. It's hovering around the sort of top 10, top 11 TOB index. It was, as you can see here, 11 having risen. Stack Overflow survey has it at number 12, and their most loved page actually has it at number 5, as you can see in that top diagram. IEEE Spectrum, GitHub Octaverse, it's all 10. And I saw the /data survey today was also at number 10. So systems like Docker and container systems and Kubernetes all written in Go, certainly an upcoming language for systems development, fast applications. So it's becoming popular, people are liking it, and I'm sure you will too. So what does it have? fast compilation, simple cross compilation. Binaries are standalone and have no dependencies, with the proviso that that's only true if they're written in pure Go. Unfortunately, when we start working with the Oracle data space, we still need a C library, a provided shared library. So it's not quite true in that case, but in general, very efficient language, a lot of built-in primitives, easily extensible, all the standard things that you'd expect from a modern language. So we had some discussion what to call this slide. It's really, what Go doesn't have, if you want to put it on the negative side. But of course, the positive of that is that it actually simplifies a lot of things. So it doesn't have exception handling, it doesn't throw exceptions which you somehow have to cache and remember to catch. You just have simple error handling. You actually have to test an error return value. Uses structs and inheritance. Doesn't have a conversion, so you explicitly have to specify types and do conversions. It's obviously a living language, a lot of interest in it. Things like generics are under discussion at the moment, so there is a good, strong path forward for it. Types, as you expect, standard primitive types. Put in things like the rune and the byte there, as you can see. These are things which you come across. You get single characters, you get multiple byte strings, complex types. Functions are first class, so you can pass them around with kind of pointers. Maps are like Python dictionaries and objects or objects in JavaScript. Channels at the bottom right, used for Go routines. I've got some demos of that later. So let's move on to the first demo. So hopefully you can see the screen there, split screen. On the right is a source file, on the left is my terminal window. This is a most basic hello world example for Go. Everything has a package declaration, and you can have multiple files in a package, and the scope of variables will be across all of the files in that package. I'm importing another package, so this is a pre-supplied formatting, as you can see lower, just to do some output if I want to do formatted print lines. What else have we got here? Lowercase means things are private. And if you look at the actual syntax, you can see on the right, if I just run it, pretty obvious, it's just going to print hello world. That does the interpretation, but if I want to build it as a standalone binary, I could do this go build and actually just build the binary itself. That would give me a 0, 1. It'll actually give me a binary on the left, as you can see. And since this is pure Go, I can actually do a cross compilation and build it as a Windows binary. So I'll end up with a Windows exe at some stage when it decides to wake up. Oops, I didn't want to do it twice. I wanted to do that one. So then I've actually got the exe. So I've actually just built a Windows executable here on my Mac machine. So that's all fun and games. I wanted to jump ahead and look at, what else have we got? Channels. Just going to sort of keep deep diving in, and you'll pick up some of the smaller details as we go ahead. So this is an example of channels, which I'll flesh out actually a little later with some Oracle database examples. So this is an example of Go routines. So this is one of the powers of Go, is that you don't have to worry about things like threading. In fact, these Go routines may or may not run in threads. You don't really get to control that. It's all hidden. So these 3 Go routines are going to run in parallel. So I'm going to call this function calcsum 3 times, and they're all just going to run in parallel. They're communicating with this thing called a channel. I notice this is implicit type declaration. I didn't have to specify a particular type. It just knows that this is going to be a kind of channel type with the : sign. And arrays kind of slightly backwards. If you're used to the C syntax, you get the factors array first before the type, and then we obviously get the initializers. So we're just passing in 3 arrays down into this calcsum function. Let's have a look and see what that does. Just prints out all the sums. So at the end here, we're passing into the channel. So you're writing into the channel. It's like a pipe, and only one thing can write into that channel at a time. Passing it in the calculated sum. And obviously at the bottom, we're just waiting for the channels to come back, and this will wait until there's something there. I thought I'd just show that one just so that I don't have to explain some of those details a little later. Let's go back to slides and continue on with the meat, which is the database SQL package. So database SQL is a pre-supplied package, common database access layer. So various database vendors implement this, has powerful capabilities, and it's built in for all the databases. Some of you may know in the PHP space, there's something called PDO, the PHP data objects, generic kind of layer. And beneath that, then you'd have a driver, which in Oracle's case is PDO_OCI. Similar thing here, the database/SQL is the top generic layer, and then we have a driver underneath, which is specific for Oracle, and I'll talk about that in a minute. Generic layer provides a lot of useful support, like the Go routines we just saw, has some connection pooling, which I'll talk about in a bit. Lets you do things like break reset, has this thing called a context management. So it lets you do a interruption of your code flow if you want to make sure you're time bounding some execution of statement. So it provides a lot of that upper level functionality. Database type support. So it only deals with simple types. Obviously, it's a generic database package, so that has some limitations. For nulls, it has some of those types shown, SQL null int 64. Oracle, of course, predating many of these standards because it's one of the original relational database systems, treats null and empty strings the same. So actually, the driver that I'm going to show doesn't support the SQL null string type. You obviously just get the empty strings back. The driver I'm going to show also fetches numbers as string format, trying to reduce surprises when we go from that Oracle decimal format stored in the database to the binary format stored in the Go itself. My general recommendation for numerical processing is to do as much of that as possible in the database, particularly if you're doing financial calculations, where obviously the decimal format is going to save your backside a few times from number conversion, rounding off kinds of errors. So there are a couple of database drivers out there. There have been a few backwards and forwards and a few name changes. So the two main ones are this Go driver for Oracle, which is actually the one we're going to speak about. It's had a bit of a history. The maintainer there, Tamash Galaxy, ended up being the sole maintainer for somebody else's driver around at Oracle. He saw that we were doing some work with a particular wrapper layer called ODPIC, which does a lot of great abstraction to make writing drivers easier. So he started his G-Oracle project using that. And then at some stage, just for some trademarking kind of issues, it got renamed to be this Go driver for Oracle. The other driver out there is something called MATN driver, we call it internally, the Go OCI 8 driver. And that is a driver which calls the Oracle client libraries, which I'll show a little later, directly. So it has to do a lot more extra work because it doesn't have that extra wrapper layer that the Go Oracle driver at the top does. So it also doesn't support some of those things which are just available to the Go driver immediately, the Go driver for Oracle immediately. But I really should thank the maintainers of that as well, Matt Ann and Michael S11. I only know them by the GitHub handles. They like to keep themselves anonymous, but they're certainly doing some good work there and making sure that's okay. But we like the Go Oracle driver, and we've recently begun contributing to it, partly because it does use that wrapper layer that Oracle itself maintains. So just a quick sidebar there. So it is open source GitHub project, this ODPIC. It does a lot of things like resource management, simpler memory management, exposes native data types, makes binding variables a lot easier, does a lot of the performance optimizations internally, does some retries if there are connection failures and SQL statement failures. So it wraps things and makes working with driver languages like the Go driver, Godror, a lot easier. And as you saw in that very first slide when I spoke about the APIs, all of these new drivers are sitting on top of it. The Go drivers, Python, Node, Erlang, Rust, Julia, Nim, they're all sitting on top of ODPIC. You can, by the way, use ODPIC directly if you just want to use it for C programs. So enough of that. So what does the actual stack look like? I've kind of spoken in words. If you look here, we obviously need some kind of C client stack. So this is the Oracle client libraries, which you can download for free, or you may have them available already. ODPIC is just bundled with the Go driver. Don't really need to know about that, just is. Internally, this uses what they call CGO because it has to call down into the C layer. And database SQL sits on top with your app, obviously making database SQL calls. Now, Oracle database, if you don't know, has standard interoperability between versions. So whatever version of these Oracle client libraries you have doesn't actually have to be identical to the version of the database. So generally, I'd recommend updating your client libraries if possible to the latest version, which as we speak, 19.9 is just rolling out, I think in the last day or two on Linux, and AIX 19.9 came out. Excuse me. Okay, so what does that Oracle client actually provide? Why is it there? Why don't we just have a pure Go driver? Well, it actually does a whole lot of stuff. It does all those database access performance things, does a lot of the high availability at the low end and the high end, including things like our transparent application continuity features. All of that's embedded into that library. Those are huge benefits to customers who want guaranteed kind of uptimes and users not to be aware if a database instant goes down and that the work can be replayed against another instance. It's just a great solid layer used by, as you saw, a lot of those other drivers. So yes, so we lose some things, but we gain a whole lot of other actual high benefit things just for the fact that you can't make a single standalone binary. So I think you win overall. OracleNet itself does a lot of things. You get things like the encryption and more. So you won't find notes about encryption in the driver documentation so much because actually that's configured at the OracleNet layer through configuration files that I've mentioned on the slide. Oh, and the other thing that I noticed is that ODPIC and the Oracle client libraries do things we call statement caching. So if you execute a statement multiple times, they can record the fact that the statement was executed. We don't have to ship metadata about that statement and the column types backwards and forwards between the database. It makes it faster to look up in the database where that information is because it's all keyed instead of having to parse a statement. So the Godror driver actually inherits all of that through ODPIC. In the last couple of days, the Go Mat-End driver has tried to catch up and add that themselves. So we're probably just a little bit ahead of that other driver out there. But use whichever you like. Okay, demo 2. Let's have a look at demo 2. Let me just show the slide things here so you can kind of read ahead. So this is Connect on the right. So if you actually want to install the driver, you obviously have to use a fairly standard Go command, go get, and you need to know where that driver is located. I've done that already, so I don't need to rush and do that. You need that thick client that I mentioned. So on Mac, there is only instant client. We don't have a database natively. And by the way, 19.8 of that came out a couple of weeks back. And that also, by the way, now has DMG packages which are notarized. So if you're on Catalina, you don't have to go and fiddle around with giving exceptions to the shared libraries. If you want to double click on that and mount it, that's fine. I'm just showing the HDIUtil commands to do that automatically. The key thing is if you're installing these DMGs on Mac, then there's a new method to do that. So it's slightly different from the old unzip method. You can just read that to see where it copies into the downloads directory. In fact, it copies, oops, that's should be downloads there. I have various links on this machine, so it's all going to work, but that's technically where it downloads to. Package maybe source. So obviously we need to import database SQL, and we need to import our particular driver for Oracle. If you look lower down, we're just passing it by name. So this is how it registers that this is the database SQL open. And that's actually why we have the underscore here. The underscore basically says ignore this, because I'm not making any direct calls to this package. And if the Go language will actually generate an error if I didn't have that underscore, because it would say, whoops, you declared this, but you didn't actually use it. It tries to be nice for you. Standard username, password, connect strings. This easy connect syntax, host name, and my service name for the database. I said a few minutes ago, there's no local database on Mac OS. By the magic of port forwarding and VirtualBox, I have VirtualBox running, and I have a database which is accessible to me via localhost, and the port just gets forwarded from my Mac machine into that VirtualBox instance. The libdir, this is relatively new. So this whole syntax is came out in the past couple of months. This is a log format syntax, which Tamash has implemented. You might see some older variants around, but this makes things a little easier. Certainly lets you use multi-lines with the back quotes. libdir is a great way, particularly on Mac OS, to say where those client libraries are. Traditionally on Linux, you'd be setting LD library path. On Windows, you'd be setting path. So libdir actually works on Windows and Mac OS, but not Linux. But it's great where it does work, just to let you bundle your machines, your applications, without having to set external configuration. This SQL Open registers. It doesn't actually do anything. It doesn't try and validate too much here. It just does a register. If you're not familiar with Go, we're getting 2 return values back, so we always kind of get the error value back, and then the database handle. Want to do some error checking. And defer is great. If you haven't seen Go, it just says, when at the end of scope, make sure that I do a close. So if I have multiple returns, then I don't have to worry about doing an explicit close or forgetting if I've done an explicit close. Go run 021 is not going to print very much. The main thing is there's no error because it didn't connect it successfully. What have I got in Connect 2 is slight extension of this. So if you look at this syntax question mark at the end of the Easy Connect syntax, this is Oracle 19c. So if you have Oracle 19c client libraries, you can go and look at this tech article, and you can see this extra options which are now available. And this is stuff which used to be available in the configuration files, but now you can actually pass it back up through to the Easy Connect syntax. So I don't need any external configuration. So we're trying to make your apps as standalone as possible. Connect timeout, as you can guess, it says if I can't get a connection from the database in a certain amount of seconds, let's return an error. Expire time, actually this is minutes. That sends a kind of keep alive packet across the network. If there's a firewall going to kill a connection, we don't want that because creating connections is expensive. So we want to keep that connection alive. And so we set this, in this case, to semi-arbitrary time, but the example came from an example where we were running on the Azure, connecting to an Oracle Cloud database in the Oracle Cloud world, and Azure was killing things after 4 minutes. And so the general recommendation is to set the expire time to about half the kill time. So we saw this before, the defer of the DB close. This time I'm actually going to do a ping, so I'm going to do something useful. The key thing here is that this is where we actually get the connection, and it uses and then releases the connection. So it does all of that at the one operation. If we run that on the left, you can see, we ping the database. Okay, again, there's no particular error there. And I think that's what I wanted to show about this. So let's go back to the slides so we can get into the real stuff that you're probably interested in. So we saw a few of those options on the data source name, the DSN parameter. There are a bunch more. I'm not going to go through all of them, but there you can see here we've got things like the privilege operations, sysdba if you want to do DBA operations. If you want to enable events, if you've got fast application notification events coming back from your database to do load balancing across instances, you could enable events and a few other bits and pieces like that. Let's talk about connection pooling. So connection pools are important for performance and scalability. Opening connections is slow. You have to start up a process on the database server. Here, you have to allocate some memory. Obviously, if a database connection gets closed, and you've got to do that in reverse. So every serious application would actually use a connection pool. There are other options, by the way, in terms of connection pooling. There's something we call database resident connection pooling. I'm not going to cover that today, but the Go driver can use that as well. So you can use connection pooling in the database as well as connection pooling in your Go driver itself. So what we've got here is obviously 3 users, connection pool of size 4. 3 of those connections are in use. 4th is just idle there, sitting there, waiting to be used. And hopefully that's the one which is not going to get killed by the firewall timing things out. So the tricky thing is there are actually 2 connection pools in the Go Oracle driver, Godror. So, and they're both enabled at the same time, so that kind of gets confusing. I recommend using one or the other, and generally use Oracle's connection pool. So this is the standard non-Oracle connection pool, database/SQL. There are a couple of settings which I'll show you how to set, but that's the cheat sheet there to how to make sure that you're using only it and not also the Oracle connection pool. It's a kind of basic connection pool, does a little bit of stuff for you to make sure your connection is available, but not a whole lot. Technically, it's probably going to be the fastest because it literally just keeps everything open all the time and doesn't do as much as the others. But really, you're probably not going to notice much difference between using this and the Oracle connection pool, which is also called a session pool, just for sort of documentation reasons. So we tend to use those two terms, session and connection pool, interchangeably. Again, setting their max idle cons, I'll show you just to make sure you're using only this pool and not the database/SQL pool. Certainly has best support for Oracle's high availability features. It can do things like check that your connections are available when you get them from the pool. Connections don't automatically go and check some of that stuff unless you've got some of the pinging going on, and you want to make sure you're not doing any more of that than you need to for your ultimate scalability. You can disable both of these if you want. You can sort of set standalone connections to 1 and max idle to be 0 if you want to have no connection pooling, but generally I wouldn't worry about that. I'm not going to read through all of these. These are the options you have with the database/SQL pool. You can see you've got fairly standard max, opens, and lifetime settings. These are all set with those db dot methods, so they're not really set as part of that DSN connect descriptor. And at some stage, by the way, I'll get time to actually push this back into the Godror documentation, so it'll be a little easier to understand. At the moment, the Godror documentation is kind of a little bit scattered in the API documentation and some in the start of a user manual. So I'll try and put some of this into beefing up that user manual. If you want to use Oracle session pool, these are the DSN parameters. So this does all those things I mentioned, the socket checks and automatic connection reestablishment. My personal preference is to use this. You get the support for the DRCP, you get high availability features, you get support for the application continuity. So I would definitely start looking at this thing. And again, you've got these extra options there, the sort of sizing options, and a couple of extra bits heterogeneous if you want to have different database credentials as part of those pooled users. Connection class is a tag we use for the database resident connection pooling. So let's not look too much in detail, but let's go and look at the demo. And we'll have a look at demo 3. So this is the Oracle connection pool. One little thing here I've done this time is that we're using just an environment variable to get the connect string. I did that just in case I had to swap databases. I didn't want to have to edit all of my files. Passing various parameters, and notice that these are pool as it's not a pool so much as a fixed size pool. It's not a growing or shrinking pool. And this is because the real world performance team at Oracle like pools to be fixed so that there are no connection storms just when you need the database to be doing lots of work. That morning, Monday morning, when people come into the office, used to go into the office, you don't want the database to be trying to allocate all these resources, start up these processes, allocate memory just when it's trying to do actual query work. You want that pool to be fixed and stable and ready to go when you need it. Obviously, that doesn't work for everybody, but that's their general recommendation. Set max idle cons, have to set that afterwards so to make sure that I switch off that other pool so there's no confusion there. And the ping is going to get a connection from the pool, do the ping, which is going to send a heavyweight packet across to the network, across to the database. So don't do it if you don't need to. Those trips are going to affect your scalability because the database has to wake up and listen to them. But this is going to connect, do that work, and then push the connection back into the pool so somebody else can use it. No real surprises when I run it. If my database is actually up, and my machine does seem to be a bit slow today, which is a bit annoying when you're running demos. Unless actually I forgot to change all of this, I don't know. We'll see how that goes, but that'll come up at some stage. I'm going to just hit continue on. Actually, let me just run that a second time to see what it's running. And is my database up? I hope it is up for the rest of the demos. I'm just checking on my other machine. Oh yeah, I don't know what's going on. So anyway, apologies for that. Best laid plans of demos. Now you know why I've often been running slides and not demos. So this is the alternative for the database/SQL pool. Again, I'm trying to set a fixed size here, a little bit of discussion, and we need to do a little bit more research to work out the best sizes. Again, I personally sort of think you don't want to be having these connection pools growing and shrinking, so I just set these to be 4. But again, if you need it, then use it. And I'm actually just going to take a quick break. My database is working. Select star from Joule. Okay, must be something else going on there. Let's go into actual real queries. So single row queries, we've seen all this before. Doing a bind. So it's a straight select statement with a bind variable. And we have this query row method, which takes in a SQL string. And this 100 is going to be the bind value for that ID. What we've got here is a tuning parameter, which I'll get into a little later, but I know I'm fetching 1 row. So I'm just going to fetch, say that just for niceness, it's a tuning parameter. Don't actually need to do this. Just saying, hey, I'm only fetching 1 row. Don't allocate lots of memory. And scan actually then says on that row, get the data from that column I selected into this variable, which is of type string. So I know that I'm getting a last name into a string. And let's just hope this runs. And oops, and I knew I was going to do that. I'm so used to other languages. And there is something a little bizarre going on. Why can I connect with SQL Plus but not Go? Oh, do I need to do that? Am I trying to connect to a remote database? Oh, that's probably better. Okay, I probably had my environment variable set to the wrong database. That was the joy of killing my shell and starting it clean just before I ran this demo. Phew. That's good. Okay, back to normal. So scan, you'll see come up a lot of times, and we will look at multi-row queries, which is kind of much more interesting. Again, SQL statement, a bind variable, so that's going to be this 120. I'm not using query row this time, I'm using query, so I'm going to get multiple rows back. Not just 1, but 2 tuning parameters, internal tuning parameters. Again, they don't affect the rows which come back to the user. When the rows come back, it's just in terms of internal buffering and network transfers. Deferring the close, which is always good. Make sure I close the statement at the end of scope. Have 2 columns, so I need 2 variables. In this case, I'm just iterating over each row, row next, row next, row next, and doing the scan as we saw, getting each item back from each row, printing it out. Now, rows next is going to return nil on error or at end of fetch, so I have to do an explicit check to see whether there was an error there. So I do have some error handling, and I get the expected rows back. So if I was doing a huge query, and you can imagine this could be, this is well oversized for this number of rows, not getting very many, I don't need to allocate this to be 1,000, but this is simulating, maybe I'm doing an unknown number of rows in a very, very big table. You might want to be setting these to 1,000, 5,000, something like that. If you don't know what these values are, you just do some benchmarking and tuning. We have 2 values because of complex reasons to do with buffering and how this comes back on the exec, and then we have to do a memory copy across, and it's a little hard to explain unless you really, really want to get down into the details and spend probably 10 minutes on it, which isn't worth doing. The basic thing is that these are tuning parameters, batches of rows coming across the network from the database. The network has to do less work, and you need to tune these probably in your production environment. because there's going to be a memory cost for transferring lots of those rows. And this prefetch is going to cause one extra memory copy on the Go side, although the Oracle Client Libraries there. If you've got a really fast network, that memory copy may not be worth it. But it does affect the number of times you go backwards and forwards to the database. So in general, in terms of overall scalability of applications, it's better to be prefetching. Let's have a look at the page query. So the page query is a little subtle variation on that. So this case, we know how many rows we're going to get back. So in this case, we're going to get 10 rows back. Here, I'm just looping through to get batches of 10 rows. And what we're doing is using the Oracle 12.1 offset fetch next to just get a particular number of rows. Bind variables again, 2 bind variables. Offset, my offset matches, and my max number rows matches my max rows. And the key thing here is that we're actually setting the prefetch count to 1 more than the number of rows we're going to fetch. And that actually then means that we don't have to go back to the database to see, was that really end of fetch? You know, I asked for 10 rows and you gave me 10 rows, but was there an 11th row out there? No. So this is a kind of key little trick here to reduce those round trips backwards and forwards to the database. I'm going to zip on because we've got quite a lot of stuff to get through. That was demo 3. So let's go on look at connection parameter soup. This is an attempt to try and make it a little clearer to you. I don't know that it will, but if you really get stuck in trying to work out what works at what layer, then this is the slide to look at. Obviously, database credentials, we need some kind of connection string. If you've got 19C, you can be using these new extra options. If you're using Oracle Connection Pool, this is where you put those parameters. Mac OS and Windows, you can put this. And again, stop the database SQL package doing its own pooling so we don't get any sort of conflicts about who's pooling and who's releasing and what's going on. All those examples use the easy connect syntax. You can just use a connect string alias if you want. There's no reason why you shouldn't do that. This would just be the connect descriptor, and you can put all sorts of extra parameters in here, such as the ones we've been using with the easy connect plus syntax. Config.dir, something I haven't shown you before. So this is similar to the libdir, but this one does work on Linux and all the other platforms. It just means you don't have to set any extra TNS environment variable, TNS admin environment variable. Again, so you can just package up your applications. So if you're not using easy connect syntax, you get a lot of those options that you can put in the DNS names.aura file I just showed you, or the optional SQLnet.aura file. Again, the timeouts we spoke about, so the extra options there. So, in fact, there are more than than the ones I showed you for the easy connect syntax. You can enable all those network encryptions, the checksumming, the retries, the failovers, all sorts of great things there. As you can see here, this particular example does show the retry count. It says if I don't get a connection, then wait 5 seconds on the retry delay, and see if I get a connection that time, and keep doing that 10 times, which is actually quite a lot. But that may then mask a failure. If there's a transient network failure, it may mask that from your users, so users do get some results with a slight delay, and you don't have to do any error recovery yourself. If you're using service names, then we recommend using a non-default service name, because you want to be changing, you're probably going to be changing the service to actually add those extra options, such as the application continuity, which are things which are controlled at the service level on the Oracle database side. And if you use the default service, you can't change some of those things. So I think I've got a couple more slides before we go into demos. So demos 4 and 5. Now we've already done 4, so that's good. And 5, DML. So on the right, this is an example of using array inserts. I have a couple of statements up here, which, by the way, have no error handling, which is bad. And also, theoretically, in these, I should probably be doing this outside the application, or even wrapping these in a single PLSQL block, so there's just 1 exec instead of 2 execs. Again, trying to reduce those round trips backwards and forwards. Here, I'm just going to insert 10 rows, creating some arrays. I happen to know range just goes across all of the keys. And then you're just creating some data, 10 arrays of 10 of each of these kinds of data types. And I'm doing exec. So again, this is going to get something from the pool, execute one insert statement and passing 10 rows of data across at one time. So sort of one round trip, and then commit and then release the connection back to the pool. So no surprises when I run that. As long as I've set everything up. I don't think I changed that since I last tested. Oh yeah, it did work. So Australian Eastern Daylight Saving Time, it's summer coming up here. And with time running out, I do need to press on. And key thing is that this can be a lot faster than running multiple insert statements. Let me just see what I've got here. So if I go back to slides quickly, you really want to reduce the round trips. So if I was running that single exec, as I just showed you with the multiple data values, it's much faster than trying to run a loop of 10,000 exec statements. So you certainly want to be making use of array operations where you can. So the last few minutes, you can see I've got a whole bunch of demos here. I don't know what you kind of do want to see. DML returning was a slightly interesting one just because I used slightly different syntax here for binding. So again, we've got a statement with particular bind variables, the Oracle colon syntax. And here I'm just using named. So I'm just saying, hey, associate the name. And this can be useful if you've got the bind variable value repeated a couple of times in the statement. The out is also an interesting one here. So this is returning. So return whatever sysdate was inserted, returning that back out into this bind variable. So I got this extra syntax to say, hey, it's actually an out bind and put the value in this time inserted local variable, which is of type time.time. You'll find that this tends to truncate seconds, microseconds. So you want to make sure that if you're trying to get higher accuracy, you're returning things as a string. And we can just run that to prove that everything is running. And as we expect, we got the value back. We didn't need to do a scan or anything. That the bind variable just got instantiated automatically. Transactions, I think I should talk about. So, by the way, and those demos, I'll hopefully get all of these up on the GoDriver site as examples soon, so you can play with these. Transactions are interesting. We tend to open this, get the connection, open a transaction, and only at the very end do we release that connection back to the pool. But this lets you then do a whole bunch of operations. And here, obviously, not using my array DML, but I'm just looping over for purposes of explaining. And at the bottom, I'm doing the commit. Not interested in the return value here. I just want to know whether I got the error or not. So I'm basically saying I don't care whether I know how many rows got inserted or not. So transactions you'll probably use quite a lot, but make sure obviously you've got enough connections in the pool to cope with the numbers of users that are doing things. And if you are doing multiple exec statements, it can be more efficient to get that connection, do multiple execs, and then commit, rather than having to go backwards and forwards to the pool to get something, that's going to be an auto commit. So that's actually extra work in the database. So transactions can make a lot of sense when you're doing multiple operations. I don't think I need to run that. I think you know what's going to go on there. LOBs to mash has been working with LOBs, and there are two modes. There's the simple mode, and then there's the streaming mode. So if you're streaming data, you'll be wanting to use this sort of streaming mode. But for most people, using LOBs under 1 GB, this is going to be a lot faster to use the simple insert. Let me just run that in the background while it's running. You can see that actually does some stuff. Again, just setting a binary and a string insert for bind variables. And it's just, you kind of works as you'd expect it to work, so there's no magic. The magic is perhaps more in this lower example at the bottom of the screen, that's more problematic, not problematic, but just more complex to use. You've got to use interfaces and scan and read all, and it's just, well, so only use this if you need to, if those large data values don't fit in memory all at one time. Oops. So, and I am going left to right because I did want to show you PLSQL, I guess, is one other useful thing, as people do use a lot of PLSQL. Just as the last example, as I think we're hitting the end of the session. So again, we're binding, we're calling to this function which I just created up above. There's an in and an in-out bind value, and obviously a return type as well. So we need to have 3 bind variables. Return type is going to be an out, so you need to set the out type. And I happen to know it's a string, so I've declared my variable res as the string. This will be the in bind, name going in as parameter 2. And then the out is also an in, which is kind of confusing, but it's just the way it is, that this is the, so I'm going to pass it out and in at the same time. So passing P2 in and out. So, and we run that and get our result out. It's just the concatenation of the first parameter with Jane, Kylie Jane, and the out parameter is the in and the out at the same time. So I think we have run out of time. I know it's always tempting to go on more and show you things, but yes, we do have advanced queuing. Yes, we can bind objects. There's a lot of sorry, apologies, a lot of technology there in that driver. The concurrency primitives in Go make it really convenient to use. We've got support now because we've got Oracle doing some contributions to this third-party driver. So again, it's not something we maintain, unlike some of the other drivers. It's something we're just contributing to. But you can certainly contact us if you have any queries or issues. I know last time I gave a similar session, somebody asked whether it's production, and we do have people using this driver in production. My caveat for that is that Tamash does like to change things and it still hasn't given a sort of version 1 naming scheme yet. So I think you do want to make sure that you're actually testing it with your own test suite to make sure it does what you want. But I think you'll find it will stabilize in the areas that we're looking at pretty rapidly, and it's as I say, in production and stable for a lot of people already. So with that, I will end the session. I don't see any open questions on the Q&A, but I will pass back to Suresh, the moderator, and hopefully you'll enjoy the session and we'll be able to look at the replay as it comes online. I think it's going to be online for a couple of weeks if I remember rightly. Thank you very much.
Yep. Thanks, Christopher. Thanks for your time, and thanks to participants for joining the session. I don't see any questions either, and we can end the session now. Yep. Thank you.
Thank you, everyone. Bye-bye.
Everyone. Bye-bye.